We are going to start slowly, very slowly, super slowly. But at some point we have to start, even if the schedule is a bit like floating, because the real schedule is the plenary of Roni in 1 hour from now. We thought with the co-organizers of the conference that it was very important to give you some context and some background, because you are here to a conference which I like to think is not any conference, because it's a topic which does not exist yet. So somehow you are participating to, I would say, a human experiment. Some of you work in quantum thermodynamics. I actually see lots of nice faces from quantum thermodynamics. Some of you work in quantum information, quantum error correction, quantum software, quantum hardware, enabling technologies, physics, information. And actually, currently you are all in your community, and the game of this conference is going to be to create bridges between this community around one simple question, which is how can we reduce the physical resource cost of quantum technologies? How can we optimize the energetic efficiency of a quantum technology? And that will be the purpose of the conference, to see how to deal with this very simple question. And so thank you a lot for being here, for being curious. Thank you to our sponsors. You see all of them on the slide. And yeah, we are going to give you, like I said, a little bit of context. So first of all, I'm Alexia Ofev. I should have maybe started by this. I'm a CNRS researcher, director of the International Research Lab, MAJU Lab. Yeah, so the purpose of this introduction is to explain to you what is the Quantum Energy Initiative, and then to give you a little bit of meat on how we are going to organize this workshop and how you all guys can become active in creating this new research field. So what is this Quantum Energy Initiative? As you're going to see, it's all about efficiencies. So what is an efficiency? An efficiency, it's a concept that emerges if you are a lazy human being and you don't want to do a task, so you build a machine to do the task at your place. And then this machine, it will do the task with a certain metric of performance, but actually you need to feed this machine in the first place with energy, obviously, and with any kind of resources. Then the efficiency, it's just the performance divided by the resource cost. And the purpose of science and technology in general is to increase this efficiency, right? So the first efficiency that we've been learning when we are small at school, it's Carnot efficiency in classical thermodynamics. But there is another field which is very aware of the importance of energy efficiency. It's classical computing. In classical computing, the performance, it's typically how fast your computer can execute operations. So it's usually counted as a number of floating point operations per second. And then you divide this performance by the power you need to give to your computer so that it does its job. So this performance per watt, it has the dimension of the inverse of an energy, and this is what people have been using to rank the computers that were bigger and bigger. And it actually appears that this energy efficiency, since the beginning, since the birth of computers, it has increased. It has doubled every 18 months. This is known as Moore's law, and this Moore's law, no, not Moore's law, Cummings law. And this Cummings law is actually the counterpart of Moore's law regarding energy efficiency. So we have a certain state of the art right now. But what we have to face with classical computing is that this QEI's law, it has saturated. It's been almost 13 years, it doesn't increase anymore. And the net result is that the information communication technologies bill has exploded, and we are now at more than 10% of global energy consumption, just for these technologies. So we need for a paradigm shift, and actually this paradigm shift could be brought by quantum technologies and quantum computing. So, but what is the promise of quantum computing? So some of you, not all of you, are actively working at developing the quantum computer. The promise of quantum computing, it's increasing performances. That's basically why there are billions of dollars that currently are poured in the field of quantum computers and quantum technologies to increase the computing power. So the number of physical operations per second that your computer will be able to execute. And with this, people are running after two regimes, basically. The regime of what is known as quantum computational supremacy, where a quantum computer can do what no classical computer could execute. And since supremacy is not a word that is politically correct, now we rather like to say the quantum advantage. So when a quantum computer computes faster than what a classical computer can do. Okay? So that's the promise. And obviously this promise comes with on a bumpy road because there is noise. So we know that to correct the noise, we need to practice error correction, fault tolerance. Ergo, there are more physical operations. Ergo, the quantum advantage is not guaranteed anymore. And so currently, what the quantum computing community is working at is to study what is the noise resilience of quantum supremacy and quantum advantages. And how can we define use cases, interesting use cases. All this to say that currently the focus of the quantum computing community, it's more on how fast can I compute than on how efficiently can I compute. And this is actually a very different target. It doesn't mean, if you try to compute fast, it doesn't mean you are going to compute with efficiency, energetically speaking. So one incentive of the community we are currently building is to study if instead of running after a quantum energy, instead of running after a quantum computational advantage, we couldn't run after a quantum energetic advantage. Meaning, can we develop machines where the quantum beast would compute with less energy than the classical? So this would lead us to have at our disposal a quantum energy advantage and possibly quantum energy supremacy. Can we do that? The fact is that right now, this is not a topic that has been properly studied by the community. And actually, if you ask the question in any conference, do you think there will be an energy advantage to quantum computing? Or do you think that the quantum computer will need like 10 nuclear plants to do its job? You will find basically 50% of the people for, 50% of the people against. So there is no clear answer to this question. And to be honest, something that is extremely, we are between us, tiring as well, is the quantum hype. The fact that there can be overselling, and when there is overselling, it basically means that there is no clear figure of merit and there is no clear methodology. And this is basically what we want to do here. We want to develop new methodologies to understand and optimize the cost of quantum technologies in their full stack. So taking into account everything in ways that we are going to discuss later on and all along the conference and in the next conferences, I hope. We need to define objective figures of merit of energetic efficiency. And we need also to develop a way to practice innovation, taking into account the fact that we have finite resources at our disposal. So, and that'll be my last slide before I give the mic to Rob. The big difficulty that we have to face if we want to talk about quantum energy efficiency, it's the fact that it's an interdisciplinary challenge. Why is that so? Like I said, if you talk about efficiency, an efficiency is a metric of performance divided by a cost. And in quantum computing, the metric of performance, it emerges, oh, maybe I should have described the stack first. So this is what we call the full stack of a quantum computation. Up above here, you have the end user. This end user, it has to implement a task, and it asks the computer to do so. Meaning, he writes an algorithm, this algorithm gets compiled, the compilation creates a circuit, and this circuit is a quantum circuit, and to run this circuit, you're going to need electronics, and you're going to need, in general, what we call enabling technologies. So this is the full stack. And so, usually, the metric of performance depends on a fight between noise and control that takes place at the level of the quantum processor, you see, in the very heart here of the stack. But to have a good control over noise, you need resources. And these resources, they can come from the upper part of the stack, from counting gates, physical qubits, number of complex operations. They also come discussed from the lower part of the stack, which is everything that is related to cryogeny, everything that is related to lasers, every technology that is here to build a classical context around the quantum processor. And that's the major macroscopic resource cost we need to take into account. And therefore, to optimize efficiencies, we really need to connect all these expertise to end up with something that is completely consistent and forget nothing. And that's the purpose of the Quantum Energy Initiative. And that's on you now, Rob, to describe the rest of the story.
Okay, thank you, Alexia. So I'm Rob Whitney. I'm one of the other organizers and members of the Quantum Energy Initiative. So I'm going to slightly change subject and talk about where we are with the Quantum Energy Initiative. So I'm going to switch from science to community, let's say. So the timeline is here. You see it's all very recent. It all started about 18 months ago when Alexia wrote the white paper in PRX Quantum, where she coined the term, which we'd been discussing a little bit the thing, but we hadn't given it a name yet, and it was the Quantum Energy Initiative. And then rather quickly, 4 of us who are circled in red here decided to actually create basically a website. That's how we started, and see if there was a community of people who agreed with us that these were interesting problems. And so it seems that yes. So we had a lot of people quite quickly signing up to say that these were interesting problems, which gave us courage to continue. And we have now started actually organizing activities. So this is the first physical activity. We have a YouTube channel with 2 talks on so far. So we're just starting the YouTube channel, and hopefully some of the talks here will go out on the YouTube channel in the coming months. And now we get to actually meet you physically, which is very nice. Many people who I've only seen inside a square of Zoom in the last couple of years. And we also thought it was important, us coming from academia, to also reach out to all of the companies and to see if there were maybe also industrial people who were interested. And we also had a very positive response, so quite a few people in the room. And so we were very happy that we were going in the right direction and we should actually start organizing things. So at this stage, still, there's no money involved. We're just trying to build a community. And now we're just starting to think that now we start to have a community, we should start to get the scientific questions aligned in a way that then people can, in the room, can apply for funding, can create collaborations and do things like that. But we think it's important to start with community and then worry about funding and things like that later. Just to reiterate the scientific questions that Alexia has already mentioned. So Alexia talked about quantum computing. But we can also think, for those of you in the room who are more at the fundamental science level, you can also ask the question, what is the fundamental limit? A bit like the Carnot limit for a heat engine, what is the fundamental limit for computing? So in classical computing, and quite a lot of things are known, but what about in quantum computing? If you have a certain amount of noise, what is the minimum amount of energy you can spend to fight against that noise and still do some computing? Is the answer to that question known or not? So that's a more fundamental question, which may be quite far from practical issues of cryogenics and lasers and all of this, but I think is worth addressing, and hopefully the two will, in the coming years, the two will start to meet, the practical questions and the very fundamental ones. And finally, although I think mostly here we're going to be talking about quantum computing because that's the community where we had the most immediate interest, I think it's really important that we start thinking about other technologies. So you could ask the question about, so for example, quantum communication. We believe quantum communication is more secure than any traditional encryption method. But absolute security is rarely useful in real life. So maybe the right way, or a different way to pose the question is, how secure do you need your information to be such that it is cheaper to do it with quantum communication than with classical encryption? And cheaper, as physicists, means costs less energy or less resources. Okay, so you could also ask that question, where is the threshold for a quantum advantage for quantum communication? Does anyone know the answer to that question? And how does it depend on the details of the technology, the quantum repeaters, how much energy they really consume in real life compared with doing some very sophisticated encryption on a classical computer with extremely long bit strings and all of these sorts of things. So I think the question, although I think here we're mostly going to be talking about quantum computing, questions in quantum communication, the same sort of questions in quantum sensing. When is it cheaper in terms of resources or energy to do quantum sensing rather than traditional sensing? And so I think all of these questions, as a community, we need to maybe expand out because a lot of the building blocks will be the same. So it's good that we talk to each other between communities because something that's useful in quantum computing will probably also be useful in quantum communication and vice versa. So that means we want to try and, so I've completely forgotten what's on this slide. So we also need to make a connection with, so between academics, people doing fundamental science, people doing applied science, industry, and we want to try and be quantitative and propose serious quantitative methodologies and frameworks which you can actually then benchmark different technologies against each other, compare them with fundamental limits of efficiency, how close are we to the fundamental limit or not. All of those things need quantitative methods, and we think those methods need to be developed. And in principle, it could cover all sorts of quantum technologies, from photons to superconducting qubits to spin qubits to everything else. And so we encourage you to join the mailing list, basically. That means you'll be updated about... Yes, that's why I couldn't remember what I was supposed to say.
Yeah. Thanks, Robert.
Oh. We did not rehearse, that's why.
Yeah, so that's why exactly we are building this community. I'm Raja, I'm also part of this magnificent board. Thanks. So yeah, to answer all these key scientific questions, we've created this community, the Quantum Energy Initiative community, It's mainly based around a website that is quite cool and updated regularly. And it's not our community, it's everyone's community. So we need everyone to participate, send us news, tell us what you want it to be. It's basically a network. It's not yet, at least, a foundation or something that creates research. It's something that promotes research, and as it's written on this slide, it's a bottom-up initiative, so it's really about you. Within the organization team, there is the operation team, led by me with Federico and Emily, and we are trying to make the community alive by showing around news, promoting research, and we do so via this website that we mentioned. We also have a beautiful LinkedIn account that I invite you to connect with. Every month we send a mailing list. Thanks. Every month we send a mailing list, and this mailing list is mainly based on things that you send us. So right now it's mostly job positions and talks and conference information. So please, if you have anything that you want to promote, send it to us, any of us, and we will put it in our mailing list, put it in our website. It's an opportunity for you to, spread the information. Also, as it was mentioned before, we have a YouTube channel that is called Quantum Energy Initiative. And that is feed every couple months, hopefully every month soon, with YouTube seminars that are live seminars on Zoom that you can join. So it's also, the goal is to do as many online events as we can, because as we know, online is still more energy efficient than taking the planes all to come here. So like and subscribe, as we say in the YouTube game. We have those two seminars, and I mean, I'm quite satisfied by the number of views for scientific research. I think if you are interested in promoting something, you can also come to me, and we can organize a seminar with as many, by inviting as many people as we can. So if you want to know more, go on the website, click on join us, click on participate. I guess people in this room are already within the community, but I'm also speaking to the people on camera, because yes, as is was mentioned before, this conference is filmed, and a small message to the speakers that haven't done it yet: please send me your consent form for allowing me to film you and put it online. If you don't want, it's fine also, please tell me. And with that, I give the mic back to Robert.
Yeah. So, okay, so now just to mention one more thing that is going on in the community. And the IEEE has, under Alexia's pressure, has organized a working group to look at questions of energy and quantum technologies. And the title is Standards for Quantum Computing Energy Efficiency. So the question is it, so at this stage, it's very much like a discussion, a sort of scientific discussion group. No one is starting to think, I think some people get scared, you say they're already going to put standards on things before we even know how they're going to work. That's absolutely not the spirit of this discussion group. It's just people starting to discuss what would be, or what could one day be, the sorts of things that could be standards. And of course, when we talk about technology, we have to talk at some point, when you switch from science to technology, at some point you have to talk about standards. You have to talk about the fact that a product has a certain quality, and if you don't have standards, then life becomes very difficult to evolve the technology. So I think it's important to start the discussion about the standards gently, but smoothly from the beginning of the technology, even though no one's going to write down any laws or rules about what exactly you can and can't do with the technology yet. it's important to start thinking about it. And it's something that as a fundamental scientist, a pure scientist, I never thought about before, that maybe one day I would have to think about industrial standards. But things are slowly, gently going in that direction. And there's a big sign here saying we need more experts in the working group. And I think it's important to say that you are the experts, right? There are no people in the world who are more expert on these questions than you, because the subject doesn't exist yet. So we need people who know about all kinds of different aspects of quantum systems, and you are perfect examples of that. So don't hesitate to join these working groups if you're interested in even seeing how standards work. And it's quite a fascinating world to step into, and maybe you'll decide you don't like it at all and you'll step out of it again, but at least you should see what that part of the world looks like, these engineers who are used to discussing standards in different technologies. And they also, so there's a next meeting, so on the 28th, so that's next week, 11 o'clock European time, which will be a talk on the impact of software and algorithms in quantum computing energy efficiency. So I just advertised that. So that will also be on Zoom. Some other things that we see, we're not the only people in the world who are asking these sorts of questions. So there's a conference in Melbourne on quantum energy in a bit less than a month. We're here in Singapore. There's a group Q for climate in North America, and there's a hackathon happening in France. So happened. Okay, happened. I thought it was next week. Okay. Okay, fine. So things are, and certainly, and these are the things we know about. And the other thing we would like, as part of the Quantum Energy Initiative, to repeat the thing about the newsletter, is that you probably know about many things that are not on this map, and we don't know about it, so we can't advertise them. So if you send information, then maybe we can fill up this map and fill up our newsletter. Now the spirit of the workshop. So to re-emphasize something that Alexia said, so we've organized a program that looks quite traditional with everyone giving talks or posters, but we would like it to also be a brainstorming session, that you really try and pay attention to the talks that are outside of your domain and ask the basic questions, push the speakers to talk at your level so that you can actually understand something. And so speakers, please try and remember that there are non-experts in the room, and try and at least part of your talk should be aimed that everyone in the room can understand. And right now we think we're more interested in questions than answers. So feel free in your talks or in your questions to ask open questions that you don't think you have an answer to. And we would also like to get an idea of the landscape, of the questions that interest you, of what you're working on, what you think is missing in the community, what no one is working on that you think should be worked on, independently of whether you think you have the skills to do it or not. Because the idea is to figure out who has the skills to work together to answer the questions that you have. So that's the program. We'll got one or two small changes, but nothing important. I will update the program on the website a bit later today. And so I guess you all have the program website. If you can manage to scan that with your phone from there, you can see the program. We have about 30 posters in addition to the talk, so I hope you'll all be there for the poster session. And very importantly, and we'll hear more about this in a second, so we have an industrial panel. I think that's the next slide. Yeah, okay. We have an industrial panel so most of the talk is mostly academics talking, but we have a specific industrial panel where we get to see what our industrial partners think about energy efficiency. From a practical point of view. And so that's today? Yes, today. Okay, today afternoon, yep. There's a round table discussion, which we'll hear a lot more about in a second, which is very important. That's a really big part of the brainstorming thing. So I suggest you listen, because that will be very unlike a normal conference. So to make that work, it's important that you understand roughly how it should work. And we hope it will also be fun. That's important. And then now the really important thing is to say all the people who worked so hard to make this workshop possible, and then I will stop. There's the scientific committee with Alexia doing a huge amount of the work. And then we have all kinds of people who've been doing many other things, mostly here in CQT and MaduLab in Singapore. We have the QEI team that will present themselves in a second. And we have a nice logistics people who sorted out all of the badges and made everything work nicely and sent you all of the information. And with that, I will stop. Thank you.
CQT and the quantum engineering program played a major role in the fact that we are all gathered together now. I arrived in Singapore in October 2022, presented this to José Ignacio Latorre and to Alex Ling, and then to Johnson Go, and they said, go, organize this. And it gave the initial momentum for this beautiful event. I mean, I hope that it'll be beautiful, but right now I'm quite happy with what I see. And then there were other sponsors that joined the game: APS Quantum, the Ambassade de France, A-Star, IBM Quantum, MaduLab, Kilimanjaro, and QEI. And so this is a good way to give the microphone now to Clara and her QEI team, who are going to explain to you how we're going to extract all the fuel from this conference and try to make something consistent with it.
Hello, hi, my name is Clara. I'm a PhD student here in Singapore over at CQT. I'm also one of the organizing members on behalf of QEI, alongside Toma and Marek here, who are joining me, and a few other folks who you'll see later in the week. So I'm gonna go ahead and pull up the slides. I'll introduce, this is Marek.
Hi, just 1 second, we have some nice slides. Okay. Yeah. So, hello everybody. On behalf of the Quantum Young Researchers Association, a warm welcome to all of you. A warm welcome indeed. I like to say that it's always comfortably warm in Singapore, at least outside. And so I hope you had a pleasant experience arriving, and you will enjoy your stay. This week, the Quantum Young Researchers Association will bring to you two activities. And just to begin, a short note on pronunciation. Our acronym, we are still undecided whether it should be QEI or QEI. Maybe you can help us with that. For now, it's up to your preference. We are in a coherent superposition about whether it's QEI or QEI. To give you a bit of context, QEI provides a platform for young researchers to connect, collaborate, and exchange ideas with the ultimate goal of advancing quantum research and innovation here in Singapore. We are funded by the Quantum Engineering Program, and that's why this week you will be joined by 30 young researchers among you in the audience, and we hope those exchanges that we will have here will be enriching to everybody.
So, as Alexia was describing, the goal of this week is to generate roadmaps, right? We want interdisciplinary roadmaps. And one of the exciting things about QEI being involved is that beyond being interdisciplinary, we're also being multi-generational, right? So we're bringing young researchers together with more experienced researchers, and we're hoping that together we can come up with these roadmaps together. So, QEI was responsible for, alongside the QEI board, with developing a meta structure so we can facilitate the generation of these outcomes. One of the main drivers for this will be our topical teams, which consist of 3 or 4 committed members from this community who will be responsible for facilitating the collaborative brainstorm. So they will be starting conversations, asking key questions, taking notes from the different speakers that we have, the different posters that we have, starting conversations, starting discussions, and then documenting the key takeaways. I'll introduce them in a second. So the materials and resources that we'll be using and relying on will be the program talks that you see in the itinerary, the QEI flash talks, which will be presented by the young researchers as part of the QEI community that will be happening during a poster session, and then the big culminating roundtable event that you'll see on Thursday. So here are our wonderful topical team members. As you can see, we have 1 team per topic out of the 5 topics for the total conference. So if you are one of the members of the topical team, could you just raise your hand and say hello? Now you can look around and say, oh, thank you so much to everyone who agreed to be part of this team. You'll be seeing their faces a lot, and we're hoping that we can all work together to generate the most productive conversations that we can for this brainstorm. Next slide.
Okay, the first activity which makes it a bit different than a normal conference like Alexia mentioned before is during the poster session, which will be held here, we will have I'd like to call it like short and sweet happenings at 3 points during the session, where each time 2 young researchers will do a flash talk where they are trying to give some a bit insights in their work in a very short amount of time to try to make it short and sweet, and this during 3 times during the session.
All right. So the second activity will be on Thursday. So as the week will go by, you will be making insights about the overall landscape of quantum technologies and about the physical resource costs that may arise. That's why on Thursday, the roundtable session will be the key activity where we want this roundtable session to serve as a platform to crystallize your ideas into roadmaps. Okay? So in the first phase of the roundtable session on Thursday, we will ask you to discuss among each other about a specific topic of your expertise. As you see, Lynn, our fellow committee member, prepared logotypes for each of the 5 QEI themes. So they will help you orient yourselves among the tables, and we will also be here to coordinate. The goal of the first phase is to prepare a roadmap for each QEI theme. Then we will have the second phase where we will ask some of you working at the outer tables to switch and move to the other topics and exchange ideas with the other people. The focus here will be on intersections in this second phase. And again, the goal will be to bring about roadmaps, but now roadmaps that will be spanning those intersections. Yes, and then at 4:30, the key moment of the workshop, we will be rounding out the roundtables, so you will have time to globally share with everybody your thoughts, conclusions, and the goal of the global sharing phase will be to formulate the takeaways of this workshop.
So to round off the opening ceremony of the first ever QEI workshop, it comes down to what do we need you for? What do we want your responsibility and your contribution to be? And at the end of the day, it really comes down to engaging, reflecting, and embracing difference. To engage, it means to listen, it means to ask questions, to share, to be pedagogical, to bring down what you to communicate what you work on and what your ideas are in an accessible way for everyone. We want you to reflect on, okay, what can my contribution look like beyond today? What does that participation look like? Who will be involved? Where is my contribution as part of the larger roadmap? And then we want you to embrace difference across the different disciplines, across the generations, the career levels, brainstorming styles, as well as the different solutions that we come up with together. So as long as you try your best and you stay engaged, I think that we can really get a lot out of this first ever workshop. So with that, I think we can call the opening ceremony to a close and introduce our first speaker. So thank you so much, everyone.